And we'll get started.
We are recording.
Hello, my name is Dennis Brandl, and what we have here today is an overview and some training on OPEN-SCS, which is an OPC UA working group dealing with open track and trace architecture for serialization systems. It's currently March 23rd, 2020. This is being recorded, so it can be played back at any time. And we will be working with the team here, myself and Pipero, on describing what we have. The first brief discussion, the purpose of OPEN-SCS is to endorse the use of global standards and develop the tools and guidelines that support to implement track and trace systems. Track and trace systems essentially in dealing with the pharmaceutical industries, the life science industries, but also available to other industries and usable, such that we get some seamless integration with existing systems. Track and trace systems affect a lot of a business, a lot of the enterprise business, a lot of the manufacturing sides of it, and what we're dealing with is to try and come up with mechanisms in place to make this seamless work together very well. OPEN-SCS in this training does include companies that may be competitors or suppliers, so if you're listening to this, I just want you to be aware of the OPEN-SCS rules. We have strict compliance with antitrust rules. In other words, nothing will be discussed in this meeting dealing with price or to exclude suppliers from the market or otherwise restrain competition.
Hey,
so
Dennis.
let's.
I'm sorry to interrupt. I don't know if I'm the only one. I don't think you're sharing the screen.
Okay, we're gonna have to restart then. Probably. Is anyone else seeing the screen?
Yes, I can see the screen. Here's
Okay.
Klaus from in Germany.
Okay. Yeah, let's try and restart this then. You want to stop the recording, Mike? Okay. All right, we'll restart. I guess I can. Yeah, let's restart it, Mike. I think when you see it, you'll see two lines. They'll show one is the first recording and this is the second one, so you can delete the first one and we'll start with the second. How's that? You're muted, Mike, I'm assuming. Everything. Hello, my name's Dennis Brandl, and what we're talking about today is the OPEN-SCS, which is the Open Track and Trace Architecture for serialization communication specification. This is dealing with the serialization that occurs in many industries, particularly in the life science and pharmaceutical industries, and how we can apply the OPEN-SCS architecture and the OPEN-SCS interfaces in order to give us some plug and play, some true interoperability of systems. So the purpose of the OPEN-SCS is to endorse the use of global standards and develop the tools and guidelines that support to the industry to implement track and trace systems that are flexible, scalable, and can be seamlessly integrated with existing systems and processes. Track and trace and serialization deals with a lot of different parts of a company. And in order to make all those parts work together, there's a significant integration effort that has to go on. The OPEN-SCS is dealing with that integration effort by trying to define interface standards that work all the way from your enterprise systems and even the governmental systems that may be included in track and trace, all the way down to the manufacturing systems, the printer systems, the label scanner systems in a manufacturing facility in order to give you a full track and trace capability. Now, there are many competitors that may be suppliers or customers that are working together in the OPEN-SCS working group, and we operate in strict compliance with antitrust laws. There's no discussions on prices or excluding suppliers or otherwise restraining competition. So just to be aware, this is an open system solution that is available to everyone who is working in track and trace and serialization. So just a brief overview of what we're going to talk about today: the goals of OPEN-SCS, its organization, scope, and overview, the use cases that we looked at for track and trace and serialization in order to figure out what sort of interfaces we needed to define, the services, which are the interfaces that we have defined, and we'll talk about those, and particularly how those are implemented in the OPC UA architecture. OPEN-SCS is an OPC UA working group, and as such is developing profiles and services definitions in the OPC UA form and format. But we will also be providing information in other formats, and we'll discuss that as we talk about the in development and future next steps. So we'll talk about services, we'll talk about the different profiles, and profiles are basically the agreements that vendors have and end users have to say what services are supplied, how security deals with this, and then what our future next steps are. So our mission and goal is really to specify functional interoperability of packaging serialization solutions. What that means is that these systems will integrate together seamlessly so that you don't have to go and spend a lot of money and a lot of time to integrate different parts of the system together, both across your own internal organization and to regulatory bodies that may be associated with it. So it's all the way down from your line serialization controllers, which are actually applying serial numbers to individual products, to cases, to cartons, to pallets, and checking that the serial numbers and labels are correct, to the serialization manager, which might be working at a site, which is managing the serial numbers and the serialization information that you're using within your site, as well as within your enterprise, and managing all of those numbers. And then finally to your governments and governmental bodies that may be requiring regulations of track and trace and serialization, as well as to your supply chain, which is actually part of this whole serialization issue, because you have to track all of the products through all of the different stages that they will go on. So how big is the problem that we're trying to address with serialization? Well, this came from the World Health Organization, so it's just some information to give you some idea of what happens when you have substandard or falsified drugs, which is really the issue of serialization. Fake drugs that are out there in the supply chain, they basically can kill people. They can give people the wrong drugs. They can give people things that they think are drugs that aren't. They can give them understrength drugs. A lot of this occurs because there are a lot of bad people out there, and they can make money on falsified or substandard drugs. The idea of serialization is to try and prevent that, to try and prevent the failure rates of medical samples, which are the fake drugs, which can run at 10% or sometimes higher. Tens of thousands to hundreds of thousands of deaths because of the substandard or falsified drugs, and lots of expenses. This is a big problem, and it's such a big problem that there are many regulations which are starting and going on around the world. They have started before 2018, earlier times, people have recognized that this is an issue, and over time, virtually every country in the world is implementing regulations that say we need to be able to track through the supply chain, all the way from manufacturing to the final dispensary, all of the products, so that we know and can confirm that the products are real, that they are not falsified, they're not substandard, they're not counterfeit, none of those sort of things. And this is occurring everywhere. So as a manufacturing company, you realize the fact that you're going to have to support all of these regulations. So if you're an end user manufacturer in the life science, pharmaceutical, biotech industries, medical device industries, you have to support all of these regulations as they're coming out. Now, if you are an equipment supplier to these manufacturers, you also have to recognize that they're going to need all these things in place. So this is what the situation is. This is what we're dealing with. We have a severe problem in terms of counterfeit drugs, falsified drugs, substandard drugs, and we have regulations which are requiring all of the manufacturers to move to a serialization solution so that they can track and trace all of the products that they manufacture, all the way from the manufacturing line, all the way to the final dispensary, wherever that may be. That serialization information takes many forms. It's created essentially down in your manufacturing sites where you put numbers onto the products. Those get aggregated together, or you may have contract manufacturing organizations, you may have contract packaging organizations, you may have a third party that are also dealing with this. That information needs to be exchanged in your global supply chain. This is typically defined right now using EPCIS, the Electronic Product Code Information Standard, data exchange, which is defined by the GS1. And many of the regulations that are coming out are dealing with GS1 and EPCIS guidelines and regulations and data. And what this does is this is the information that flows back and forth between the manufacturers through your distribution channel all the way to the dispensary that it may show up at, in order to ensure that the drugs and the products are actually valid, and that the ones that they are dispensing in this case are the ones that were actually manufactured. So the scope of what we're looking at here in a company is something like Enterprise Serialization Manager. These serial numbers have to be semi-random numbers that are maintained, which means that they're just not simple codes, because they have to be hard to counterfeit. They have to be hard to falsify. And you have to manage those as you're manufacturing. When you go to warehousing in most of the life science industries and many of the other industries, there is a packaging and unpackaging that goes on, an aggregation as you pull pallets and cases and cartons apart and repackage into different cartons and cases and pallets for different markets, and you need to track all of the products through that. So what we're dealing with here is a lot of complexity. Now, what we're dealing with in the OPEN-SCS world is what's shown here around the red rectangle. We're dealing with the manufacturing, and it's not just the manufacturing within the company, but also manufacturing which can occur in a third-party packaging, the contract packaging organizations or contract manufacturing organizations across the entire enterprise, all the way from your enterprise serialization manager, which is really creating the numbers, all the way down to the packaging line where we're actually printing these or laser scanning these onto the products and then verifying that they're there, through your wholesaler where you split pallets and rebuild pallets, all these systems. This is the scope of what OPEN-SCS is dealing with. And the idea of this is that we're doing it because it's a complex problem, and integration of these pieces together can take a long time. So we're talking about integrating on your packaging line, so you may have 10, 100 or more packaging lines in your entire company, and you have to integrate those with your higher level systems, which might be an MES system, as well as with your ERP systems in place, all of which can be extremely complex. Now, in order to do this, what OPEN-SCS is looking at are interfaces. So when I talk about, we're talking about the architecture, we're really talking about an interface architecture. We're not talking about how these things are actually implemented in your facilities, because there may be more than one model that you actually have in your facilities, and there may be many models that could apply. So here's just some examples of some of the architectures that we looked at as we said we needed to define interfaces. So your first one is a fairly simple architecture. We have a packaging line serialization manager, which is dealing with making sure that the serial numbers are onto the printing system and the scanning system, and making sure that the labels are correctly applied and everything is working at the manufacturing side. The site serialization manager is generally dealing with the jobs and the job orders that you have to do in your packaging line to relate the actual serial number to the product that is being made. So you know exactly what batch, what lot, and then what serial number is associated with it. That's typically what we call the ISA 95 Part 3 functionality of associating the work with the job. And then finally, we have an enterprise serialization manager is another possibility, where you have a system that is actually managing all of the serial numbers across all of your sites and simply providing those to your sites and then receiving the information that comes back and says, okay, this serial number was associated with this product, with this lot number, with this expiration date, and all the other information that you typically have to work with. Now, that's only one architecture. There's many, many other architectures that are out there. For example, some enterprise serialization managers will actually run things all the way down to the site. And if you have a smaller manufacturing or smaller medium-sized manufacturing facility or company, this may be the way that you're doing it. But we still have interfaces there that we have to define. In this case, the interface between an ESM and an LSM. Another possibility is that your line serialization manager and your site serialization manager are all combined, because you've got a very integrated system which has an MES and a printer and scanners, and all those are one package from one vendor, but you still need some interfaces up to your enterprise system as well. Another possible architecture. Another one where there's overlap, or even possibly multiple different lines and packaging lines within the same facility that may be operating in different manners. So again, we have some communications. In this case, they may go across what we would call level 3. You could go up to cloud-based systems as well. So, for example, you may be managing all of your serial numbers and the unassigned serial numbers in a cloud-based system, or all sorts of different combinations. So what we're trying to do in OPEN-SCS is define interfaces that will support all of these different architectures. We don't want to force an architecture on vendors. We don't want to force an architecture on end users. We want to say, you pick the architecture that's going to work best in your situation, and we will have an interface specification that will allow you to tell, if you're a manufacturer, to tell your vendors, this is the interface we want for your equipment, and also that to tell your system integrators, we're going to be using these interfaces, so your job's going to be a whole lot easier to make all these pieces work together. Now, one of the questions that was asked when this whole effort was started is how are we going to be doing this? The decision was made to pick the OPC Unified Architecture. There are several reasons to do that. One is that it is a very vendor-independent, secure transmission of information. It's an open standard. It is supported by the OPC Foundation, but it is also an IEC standard, so it is an international standard. And the open standard implementations are implementable under the GPL 2.0 license. But there is also a rich infrastructure of providers that give you a lot of OPC UA toolkits and services that you can also apply. It supports a service-oriented architecture, and you'll see that as I talk about how we actually implemented this. And it has very robust security. As a matter of fact, it's probably considered one of the most secure industrial networking protocols and stacks that are available. We'll talk a little bit about some of that security. And its real focus is on real-time communications, on interfacing industrial equipment and systems for data collection and control. And lastly, OPC UA is platform independent. It's not tied to any single operating system or programming languages. Those of you who are familiar with the older OPC UA Classic realize the fact that it was really working and designed for the Windows environment. OPC UA is not. OPC UA will work on Linux, Unix, OS2 if you still have it, Windows servers, any of those environments. So it is not tied to any specific operating system or any specific language out there. So we started the OPEN-SCS organization as an OPC Foundation working group. These are basically collections of experts in the field. These are end users and providers who are working together to try and define these interfaces. They work together to ensure that their unique needs are met, and it allows the OPC Foundation to support its members in the marketing and engineering resources required to actually create the specifications that we're talking about. And you'll see we've created a couple specifications which are just normal, very IEC type specifications of what we want. And then we have created something which is called an OPC UA companion spec, which basically says, using the OPC UA architecture, this is how we want to implement all the pieces of OPEN-SCS. There are, at this point in time, 11 members on the steering committee. Our executive director, Marcel from Abbott, myself, Cause, who is the subject matter expert on OPC UA. Operations manager, you can see, is Michael Bryant, and marketing director is Thomas Hoffman. So we have a set of people who are steering us, and then we also have a technical committee that is actually defining the standards and defining the interfaces. So we have a representation of end users and vendors supporting and working on this. The work was started in 2014, 80 participants, 49 companies. And you can see we started all of the work. We did a first pass at the standards in 2016 and 2017. And then we did a development of it and recognized the fact that it wasn't really working correctly. We had to reorganize and consider a different approach to the OPEN-SCS problem and issue, which is, again, what we have done. And we're working, as you'll see, very closely with GS1 to ensure that the solutions and interfaces we define are consistent with the GS1 EPCIS1, because we, as manufacturers, want to work well in the corporate environment. So we want to be good citizens. So we want to work well with the EPCIS GS1 work. And that's really what we started in 2018 and 2018. And in 2019, we released version 1 of the standard. And we had a plug fest, which started to say, okay, is the standard correct? Are there problems in the standard? Can we correct those? And we're going to do a second release of the standard here shortly, within a very short time frame. There are some OPC UA requirements for the timing of this, but we will have the second version out shortly, within the next week or so. So we are talking about the beginning of April or the end of March of 2020 to have version 2 of the standard released, which includes the refinements that we made as a result of the plug fest, and fixed some small problems that we had inside there. And I'll talk in the future about what we're doing with master data, EPCIS events, and packaging orders. Now, to make this all work, we're not doing it just by ourselves. We're working with other organizations. Obviously, OPC Foundation, because we are a working group, and the OPC Foundation has been providing us technical support. They've been reviewing the standards that we've been working on, reviewing the documents, making sure everything is consistent. We've been working with GS1, the Global Standardization Organization, which is the owner of EPCIS standards, which are the standards that are used inside the supply chain to pass information back and forth, with ISPE to make sure that what we're developing is consistent with the GAMP standard, the generally accepted manufacturing processes, such that when you put these systems in place, you will be able to validate them and make sure that they are running correctly. And then also working with ISA, the International Society of Automation, because they have the ISA 95 and 88 standards, which are heavily used standards inside manufacturing that deal with both batch manufacturing and deal with the MES, or manufacturing operations management systems, that are out there. So in working with these organizations, we've tried to make sure that we're consistent with their definitions and not redoing something that they have already done. So here's the current documents that we have available, and you can go to the website and you can pick up these documents. The first one is the Packaging Serialization Specification, the PSS, and what it deals with is the definition of the services and interfaces that we need to have, but it does it in a technology neutral way. The idea being here is that we want these things to work in more than just OPC UA when we have to move it to something other than OPC UA. So we're providing that standard definition in the PSS. The PSS was written based upon the use case, and I'll show you some of these use cases that we have. So first thing we developed were the use cases. It said these are the typical things you have to do to have a serialization solution, and it's not all the possible use cases, but it's the typical things that go on. And from that, we derived the PSS, or the serialization specification. Then from the PSS, we built the companion specification, the OPEN-SCS serialization object model, which is the companion spec, which says this is how this is implemented using the OPC UA technologies. And right now I'm showing you release candidate 1. We're going to have release candidate 2 out soon, and then go through the formal cycle to get the OPC UA release, so it will be a final specification. So these are available right now. Now, the question is, why do we want to do this? Well, there's some increased agility, more predictable data exchange with CMOs, contract manufacturing organizations, and contract packaging organizations. Likewise, most life science manufacturers, most pharmaceutical, biotech manufacturers have a lot of different vendor platforms that they're using. And they need to integrate many of these things together to make sure that they're all going to seamlessly send the data back and forth that they should be sending. So we're going to try to integrate those. Integration of platforms due to mergers and acquisitions. I have been in this industry for a while and recognize the fact that many people switch jobs, and companies with never switched desks, because sites are sold and bought, and all sorts of mergers and acquisitions occur all the time. And every time they occur, you have efforts on your IT department to make all these things work together. Hopefully, with the definitions that we have here, this becomes much, much easier to work together. And then allows hopefully the best in breed solutions, faster and predictable implementations, and then pre-validated integration and documentation. Validation is obviously in this industry extremely time consuming and extremely manpower intensive. So pre-validated systems will help a lot. For the vendors, it lets them speak a common language to their customers, one language. So we have a common definition of what we mean by serial numbers, what we mean by states of the serial numbers, what we mean by the events that have to be recorded in order to track and trace serial numbers. That should give a reduction in customization and therefore predictable configurations. It should decrease the vendor's cost and increase the speed that they are going to be able to implement these things. So these are the benefits that we are hoping to see from the OPEN-SCS. And I think that from what we have seen and what we have discussed going forward, we think there's a very good chance all these things are going to show up, and that people are going to be very happy with the solutions as they implement these, because it will be not quite plug and play, but almost plug and play. You should be able to tie these systems together without programming, just with some minimal configuration. So let's talk a little bit about the use cases and the transactions that occur. So our use cases, what we did is we focused on the ones that are in blue here. So you do have a global serial number management system. Now, in many cases, this might be your corporate serial number management system, because you have you're managing those yourself for all of your different products. In some cases, these might be managed actually by governmental systems. So you may be operating inside a governmental area that says, okay, we're going to give you serial numbers and you need to use these serial numbers. We're not dealing with those, but we are saying once we get the available serial numbers, then we start managing. We manage those serial numbers by allocating them to products, by allocating them to production runs, by allocating them to the individual batches that we're going to use. Then we, and that's called provisioning of the serial numbers. Then we print the labels, scan the labels, apply the labels, make sure that everything is working correctly. And then the labels themselves, when they're applied, that's called commissioning. That's called taking the label and applying it to a product. And I'll show you in a little bit further on where some of these terms come from. These are terms that are EPCIS GS1 terminology. And then finally, we take the product and we deliver it out, and it goes someplace into the supply chain or into the transportation chain that you may have. So what's the life cycle of these serial numbers that we need to deal with? It generally goes from unassigned, which is just a number that doesn't, that is not assigned to anything, but it's a semi-random number that is a serial number. And then that goes from unassigned to associated with some sort of packaging run or some sort of production run or some sort of manufacturing. So that you then are keeping this and saying these sets of numbers are going to be associated with this batch or this packaging run or this lot of materials. Then they are represented on a printed label, and then you may have the printed labels. Now, part of the things that we wanted to also support was the fact that you had custom labels printed, which might be printed outside by another company. And we need to tell them the serial numbers, get the labels, track the labels. Finally, the labels are applied to a product, and then that's called a commissioned label. And we're calling the product is the serialized identifier. At the point in time, it actually is part of a product, in this case, a vial or a pill bottle or a carton or a case or one of those sort of things. Then we have it, a different name for it because it's something that's actually real at that point in time. And we do this for not just the products, but also for the aggregations of the products together. So it's unassigned, provisioned, printed, and commissioned. And we do that for the individual products. So in this case, I'm showing pill bottles here. But we also have to manage the serial numbers on the packaging. So let's say on a carton. So I may have a different set of serial numbers and different randomized serial numbers associated with a carton of materials than I do associated with each of the products, because I need to track the cartons as they go through the distribution centers and breakouts. Whereas I need to track the bottles themselves, the pills themselves in the bottle all the way down to the dispensary. And then also I may have to do the same thing for a pallet. So many times full pallets of products are manufactured and then shipped off to warehouses. Those pallets are split apart and create other pallets that may go to the distribution center. So one distribution center may get 5 different products on a pallet. Well, the serial numbers on the pallets that I need to track are also unique and also have to be tracked and also have to be assigned and unassigned and provisioned and all the others. So we do have several different serial number pools that need to be managed, but we need to deal with not just the products, but also the aggregations of the products together. To show you a little bit more detail on what we're talking about for serial numbers, their life cycle and the associated events. You know, serial numbers start, as I said, they're unassigned. They come from a corporate or intercompany or governmental bodies. They may come, you know, if you are a contract label printing organization, they're going to come as part of your order. It's going to say these are all the serial numbers that I want to have applied to these labels, because eventually they're going to show up be applied to my products. They may come from governments that simply say, here's the numbers you can use. They may come from your corporate systems that says, here's the numbers you can use. Semi-random, but each one is unique because we're talking about tracking every single product that goes through the dispensary. Numbers can be kept in a pool of unassigned, but really they're generated by algorithms. You don't keep, 6 billion numbers as unique numbers. You have an algorithm to use to create these things and to ensure that you do have uniqueness of them. And then if you have a global system in place, you may want to be able to return unused serial numbers to the pool. So for example, I may have a whole set of serial numbers that I say that I want to pass down to be provisioned, but maybe I send down 1 million of them, but I only ended up making 900,000 products, so there's 100,000 serial numbers. I need to report back that those serial numbers are no longer valid. So I either can return them back to the pool so that they could go to the next product or the next assignment, or I need to indicate that those are invalid. So again, serial numbers have values. They don't have value intrinsically, but they have value because somebody can falsify or counterfeit a drug using these serial numbers. So if you were to send down 1 million serial numbers and you were not to indicate that 100,000 of them were not used, somebody could get at those 100,000 somehow, electronically or somehow, and then use those serial numbers, and they would appear to be valid, and that's not really what we want to do. So what we're calling is, from unassigned to the next state, is provision. And the provision state, they can be unallocated, which means they're not yet allocated to a batch or a production run. Many cases this happens when I have multiple production lines or packaging lines that are out there, but one system that's in charge of them and running them all. And I may make late minute decisions as to which line I'm actually going to be running a job on. So I want to keep the numbers unallocated yet to a specific packaging line run, and then they become allocated to a specific run, to a specific product, to a specific production run or specific batch. These numbers are then available for encoding onto a label. So these are kind of the states that a serial number goes through, and what we're trying to do here is show you all the states and all the events that can occur as a result of that. So once they're available for encoding on a label, then the labels are printed oftentimes, and then you'll see that they can get attached. Now, in some integrated lines, the printing and the attaching is a very rapid process. I mean, we're talking about, you know, they're very close together, they occur in line. But in other systems, you may actually print the labels, put the labels on rolls and spools, and then feed the printed labels into your production line. So you want to be able to track the printed labels. But it's not just the printed labels that you're tracking, because several things can happen to that label. One is the labels could be scrapped. So if I have a serial number and the label fails, and maybe the printer runs out of ink or the label is ripped or something like that, I still need to track that serial number, because I don't want that showing up in the supply chain. I don't want somebody to go through my trash and find all the scrapped labels and say, oh, I can just put those numbers onto my counterfeit drugs and I'll make a lot of money. No, instead what we have to do is we have to record the event that this label was scrapped, and therefore that serial number is no longer valid. Likewise, if you pull off labels for samples, and in this case, this is required by some governmental regulations where I have to keep a physical sample of the labels themselves as part of the paper record that I have on production, well, you need to pull those numbers off, because otherwise somebody could get an access to those numbers, and you would think that they were valid numbers, but in actual fact, they're not valid numbers. They're sitting in your lab or in your filing cabinet somewhere. So you need to record the fact that, yes, these labels should never show up in the supply chain, but they're valid labels. They're valid labels. They'll never show up in the supply chain. The next step we have on that is, once we've got these labels, once they're encoded, and you can even record the events that says, yes, I have inspected these labels and everything is fine. Again, could be coming off a contract manufacturer. It could be coming off a pre-printed set roll of labels that you use. They then get applied to the product itself, and that's called commissioning. So once it's commissioned, as I said, we're calling these things SIDs, we have the same sort of things. If I can pull some of these commissioned products off and retain them for samples, I can send them to the labs, I can send them into the warehouse if I have to do stability checks on them. And again, I don't want these serial numbers associated with these products to go in the supply chain, so I need to record the fact that they're valid numbers, but they'll never show up in the supply chain. Likewise, I may have to destroy some products depending upon how you do your manufacturing and how you handle failures in the manufacturing. I've got a product, it's got a serial number on it, but I destroy the product, I need to say that that serial number is no longer active. Likewise, if I send it to the lab and I test it, then it may be decommissioned. It means the product's no longer active. For terms for what we used, we're using an EPCIS term called shipping right now for the event that says this is moving from the responsibility of the manufacturing and packaging line into the transportation, you know, or to a warehouse or something like that. So that's the event that goes out that says, okay, it's out of manufacturing, now it's being tracked, and it's going to be tracked using your EPCIS GS1 sort of tracking system to make sure that it's there. Then we also have packaging and unpackaging to do the aggregations. So for example, we may say one of these, because I'm showing this right now for a product, but this could also be for a carton or a case or a pallet or any of these other sort of aggregations that are out there. And I can unpack the aggregation and repack it with something else in there. So all of these things are the events that we are trying to track in order to ensure that any serial numbers that should show up in the supply chain are valid, and any numbers that should never show up in the supply chain have been notified and has an event associated with it so it can be tracked. Now, what we're using here is GS1 event terminology on the right-hand side of this state model: commissioning, destroying, inspecting, decommissioning, packaging, shipping, etc. And then we're using OPEN-SCS event terminology on the other side. This is just the additional levels of detail that we need to manage the events that are occurring inside the manufacturing facility as well. And we have very unique definitions of this in the PSS, and you can see where these terms actually come from and what they mean. But as you can see from this, we're trying to be very, very consistent with GS1, very consistent with EPCIS, and making sure that our terminology matches their terminology. So these are the events, these are the life cycles that we need to go through in terms of managing what a serial number is, all the way from a number, which could have a value, all the way to the final product, and then all the things that happen to that serial number so that we can track it and ensure that if the product ends up in the supply chain, that it wasn't a destroyed sample, that it wasn't an inspected sample, that it wasn't a decommissioned sample, that it wasn't a scrapped label, that it wasn't a label that went into the batch record, paper batch record that somebody just got a copy of, or that they grabbed the serial numbers early and they weren't invalid. So all those things are done to protect the integrity of the serial numbers, to protect the integrity of the commissioned products that are associated with those serial numbers. And again, just to point out, we're not defining architectures, we're defining interfaces. So given that life cycle and given these different possible architectures, that is how we define a set of interfaces to make all of these pieces work together. Now, so this is one example of it. You know, other examples that came out pretty regularly in the discussions of the use cases and the discussions of the PSS specification was, I may have a separate enterprise serialization manager, which has to work with my ERP system. I have a site serialization manager that has to work with the MES because I need to know jobs and job orders and packaging orders, and then line serialization managers, which may have to work with my PLCs or my DCSs or my open control systems. So a lot of possible interfaces that need to be defined. And then they have to report to governmental systems and supply chain partners. That's one possible set of implementations. Another one is maybe your ERP includes your serialization services. Many of the large ERP systems will provide that as options. Maybe your MES or MOM system will actually provide the serialization services, and we have several vendor members of this where that actually occurs as well. And we have members where all the different options occur. We have members who look at the line serialization services as part of the entire package that they provide to an end user. So again, another set of services. So you'll see that when we built the service and service definitions, we will have defined profiles that allow you to custom configure what your system provides, so that you can explain, you as a equipment manufacturer can explain to the pharmaceutical manufacturer exactly what services you provide, and then they can look at it and decide how to integrate those together. So here's the sort of use cases that we talked about. So we have an ESM to an SSM to an LSM, for example, and it's requesting serial numbers. So it's basically saying, you know, I am a SSM or an LSM, and I need serial numbers to operate. So if we take the simple case, I'm a line serialization manager. It says, okay, I'm supposed to run this job. I need a bunch of serial numbers. Okay, so I'll request 800. Maybe 800 is the most I can request at one time because that's the space that I have available on my LSM. I'll get my response back. I'll generate a request for the next one until I'm finally done. So this might be an LSM that has limited memory that's requesting a set of serial numbers so that it can apply them to labels and then commission the products. Likewise, it could be a site serialization manager talking to an enterprise one saying, okay, I was given an order to make 1 million products. I need 1 million serial numbers. So it's going to be requesting those. The same interfaces we have defined could work from the LSM to the SSM, or from the SSM to the ESM. Those sort of, both of these things are essentially the same interfaces. I'm simply asking for serial numbers that happen to be in a slightly different state. So there's a pretty typical sort of thing. I'm going to ask for a set of these. I may not be able to get all that I need in one request. I may have to make multiple requests to it. There could be several reasons for that. There could be because I have internal memory limitations, or it could be because the sending system said, I'm only going to send you, 10,000 or 1,000 at a time, and you have to ask for it in 1,000 block chunks. Now, we can also request serial numbers, but have some sort of delayed response. So basically, I'm asking for serial numbers, but I get something back that says, nope, they're not. I don't have them yet. Some of these situations occurred because people were talking about governmental agencies that were actually giving them the serial numbers. So when they did a request on it, they were not necessarily going to get these back in real time. Likewise, I may be talking to a corporate system that I don't want to overload. So I'm going to say, give me a set of serial numbers, but you can give them to me in chunks, or you can give them to me as soon as you get them. So you have some sort of request token that comes back and says, yeah, I can give you numbers, but not all of them yet. And then you come back and ask for them again. So even though the first one was really a synchronous transfer, this one is a little bit more asynchronous because you're providing feedback that allows you to then resume or continue the transaction that you had to actually get the serial numbers that you need. Again, same sort of thing could occur at multiple different levels of the system. It's just the numbers and the states of the serial numbers would be different. Likewise, we had a use case that said, okay, I've got a set of serial numbers. I'm not going to use them. I was told to make 1 million products. I made 990,000 products, and I have 10,000 serial numbers that I either want to return to the pool or so that you can reassign them, or you can mark them all as invalid. So we have a service that says, okay, how do I return serial numbers? How do I, as an LSM, say, I was told to print, I was told to make 1 million products. I ran out of product at 990,000. Here's the 10,000 serial numbers I will not be using. I don't want you to assume that they're going to be in the supply chain. I don't want you to assume that they're going somewhere else. I'm going to return them back to the system that is managing them so that they can mark them as being not associated yet with a product. And we do the same thing. We have an LSM to SSM or SSM to LSM. Same sort of services. It just depends on who is talking to who. Now, not all times will the lower level systems be able to ask for data. So I may have, I'm going to call it a not quite intelligent line printing scanning system, and it's not going to be asking for information, but it needs to be told, here are the serial numbers for you to use. Likewise, I may have an enterprise serialization manager that says, okay, I'm going to send down an order for, to make 1 million products, and I'm going to send you down 1 million serial numbers at the same time. So I'm going to push those down. So instead of a pool, which was the previous one, this is a push that simply says, here's how I'm going to push these numbers down, maybe push these numbers so they can be encoded to a printer, or push allocated to be unallocated. So my enterprise system will push a whole set of numbers down, or unallocated to allocated, any one of these sets of services. So we have services that and both sides that say, okay, here's the push. Here's how I can push a set of numbers down to a system rather than that system asking them for those numbers. Then we have event reporting, because not everything is dealing with allocation of serial numbers and managing the pool of serial numbers that we have. The other thing that we have to deal with are the events of the serial numbers. So, you know, what serial numbers are now invalid, which ones have been sampled, which ones have been destroyed, which ones have been shipped, etc., and all these, which have been commissioned. So we generate the serialization event and send it to an event manager, essentially, that will be receiving it and processing it and performing whatever business function it needs to perform once it's received the events associated with it. And I'll show you some of the events, and again, they relate back to the states that we have and what they actually meant. You know, so I can have an enterprise serialization manager that is accepting the events that are all the shipping events that says this pallet was shipped, these products were commissioned, these sort of things, so that the enterprise serialization manager can update its databases and keep track of all those things, so that when it gets requests from the distributors and from the wholesalers, you'll be able to say, yes, that's a valid number or not. So you can have this, in this case, you know, I may have an LSM to an SSM. So the line serialization manager is saying, oh, these labels were scrapped. These labels failed, you know, my printer ran out of ink, or the labels got torn or something like that, or they didn't get applied correctly. You know, something happened with my carton or my case packer or something like that. So they need to report those events back. Likewise, at the higher level, the SSM might be reporting back to the ESM and says, okay, here are all the products that were commissioned. Here are all the serial numbers that were commissioned. You know, here's all the labels that were sampled. Here's all the products that were sampled, et cetera, and all these other events that can go out. And likewise, you may have to report your ESM up to a governmental agency. It simply says, here's all the products that were commissioned. Here's all the numbers that are in there. So if you have to track at a governmental level, you have the information to know what's valid and what's not valid. So we've been talking about serial numbers, but in order for that to work, you have to have some master data, which is common across all of the systems. And that master data is the material codes that are associated with it. So you have a unique way to identify each product that's out there. The names of those products, various other things associated with the labels. So for example, the master data says this is the information that needs to be printed on the label. It's the batch number, the lot number. Here's the format for the lot, for the date, the expiry date, and all these other pieces of information that may have to be associated with it. So what we're working on rapidly now to have out in the next 2 months is version 2 of the standard, where we're talking about the master data, both with a push of the net master data and a pool of the master data. And to do that, we're actually going to be using some already pre-existing work. As I said, we don't want to invent new stuff if things already exist. And the ISA 95 model already has a set of definitions of master data and how to represent it. And the OPC UA Foundation already has a companion specification that talks about how ISA 95 can be applied in OPC UA. So we're not going to have to recreate something. We can simply reference existing documents that have already been out there, and they've been out there for a couple of years. So we already know that they are going to work. And then for the, it's basically a push of master data. So many times what will happen is a company will push down on a regular basis from their business level systems to their lower level systems, the material codes that are available, basically the material master information, because that's managed at your corporate level, at your enterprise level. Some systems will also allow you to request some of that data to pull it back, you know, so you may, for example, have a system in place that allows you to go say, okay, show me all the new material codes, show me all the new label formats that have been approved or changed for the last day or so, something like this. So you have a couple of these use cases that show how to do master data. That's, as I said, is version 2 of our use case and version 2 of our PSS, which will be out very shortly for the final review and final approval. And then we will develop the OPC UA companion spec release candidate 1 for that shortly thereafter. The other thing that we're working on, again, there's a bit of a future, is the version 2's work is to say, okay, how do we handle the packaging order? And again, we're looking at the ISA 95. ISA 95 Part 4 has the definition of a thing called a job order, which is really, a packaging order is just a very specific type of job order. It already defines the information that you could send down as a result of the job order. And then we have added some of the controls associated with the job order, so you can download the orders. So I may download 5 orders to my MES system or 5 orders to my packaging line and simply say start them. As soon as one is done, start the next order. Or I could download them and then at the time decided by the higher level system, tell it when to start. Maybe I need to update an order because something changed. Maybe I need to cancel the order. We have various different services that we're going to be providing there too. Again, all based upon the ISA 95 model. So here, for example, we generate a packaging order. That order is processed. Maybe I have to respond back and say, yes, the order was acknowledged, that I received it, but it was received, but I haven't started it yet. So then I start the order. Then likewise, the information provider may need to generate serialization events. And then at the end of the production order, send some sort of response back that simply says, okay, I've completed this entire order. Here's all the information associated with it, the things that you may need to know, such as how much material was consumed, how much material was produced, what equipment was used, all the sort of things that you would need for tracking of the system together. So these are all the use cases that we use to write the specifications and to define the services that we needed. So the next piece here is to say, what are the services and how did we use these and how do these end up being part of the OPC UA architecture, and how will these work together to allow you to build a plug and play integrated system with minimal configuration needs. So the reorganization that we did in 2018 was basically to move to the OPC UA methods. Now, if you're not familiar with that, let me just explain that a little bit. OPC UA represents the information to be exchanged as objects. So software person, you know what that means. It's a collection of data, and which has a very unique structure and well-defined structure. There are in OPC UA a part of it called methods, which are defined in OPC UA Part 3, that are basically service calls on these objects. So they're invoked and they return upon completion, successful or not. They allow transactional requests and associated data. Now, if you're familiar with the older OPC UA, or the OPC, and you think OPC UA, it's basically to exchange tag data, to exchange information about, the sensors and the actuators and collecting the information you need for historians and others. Yes, that is what OPC UA does, but it also provides other services. And these services, as you'll see, are the methods that we have defined. So basically think of it as just a remote procedure call on an object that exists inside OPC UA, and I'll show you what some of those objects are here. But it is a software version of object-oriented programming that we can use to define the services that we want. Remember I said that OPC UA was a service-oriented architecture, and it really is. And it deals with certain objects. So the objects we've defined is a pool manager object. Remember I said serial numbers can be maintained in a pool. They can be unassigned or assigned pool or an allocated pool of numbers that need to be managed. And from that pool, I can request them, or I can return them, or they could change states. All these things can occur to it. Likewise, we have an event manager object. The event manager object is the receiver of events. So your enterprise system is probably an event manager object because it's receiving events about commissioned products, and it's receiving events about, destroyed products or invalidated products or shipped products or sampled products or all the other things. So it's receiving events. So we have an object that receives events. We have an object for the aggregation. Now we split this one off specifically because when you look at warehousing and other systems like that and distribution centers, they don't need much of the pool management. They don't need some of the event management, but they do need to be able to say, yes, this pallet was pulled apart and these things are now on this new pallet. And then we have an SID class which is the basic information about the SIDs. Remember, I said those were the commissioned products. Those are the things, they're a product with a label on it, and there's much information about that, such as, you know, the labels, the expiry dates, the lot numbers, and all the other things associated with it. So these are the kind of objects that could exist inside an OPC UA server. Now, not every server supports every kind of object. So here's some sample structures, and they are just sample structures. Okay, so system one here, it's basically just a system. All it does is it manages pools of serial numbers, maybe assigned or unallocated serial numbers. So you can request them or you can return them, and it may be able to push them to other systems. That's all it does. On the other hand, system two, maybe it's a much more complex system. Maybe it's a complete MES or MOM system out there, and it handles multiple serial number pools. So I'm going to manage a pool of allocated, and manage a pool of unallocated, manage a pool of commissioned, all these other things. It's going to receive events from lower level systems. It may have aggregation events and manages multiple different SID classes associated with it. So when you are configuring your server, which is what your equipment vendor tends to do, they will define the objects that will exist within their system. And that's part of the configuration of their system. It says, I'm going to manage 3 pools, I'm going to manage these kind of events, I'm going to manage aggregations, and then they create or configure the software elements within their system to handle those sorts of objects that are out there. This is to make it easy for the vendors because they can decide exactly what functionality they want to provide, and easier for the end users because they can look at a vendor, an equipment vendor solution and say, oh, okay, you will be managing this. I don't need this part of it, but I do need this other part of it. So you get to pick and choose the functionality that you want to implement that the equipment vendor actually supplies to you. So here's the pool manager object type that we're talking about, and it handles a couple things. It uses the push of numbers. It handles the pool of numbers. Remember, I said there's a push that says, here's the numbers you need to use. You didn't ask for them, but I gave them to you. And then, or the pool, it says, I need numbers of some state, some status, and I can request those. You'll see that the names of these things really relate to the states that we had talked about before, and I'll come back to those and show you. So it handles the push of numbers, the pool of numbers, the push of unused numbers, and exposes the pool selection criteria. So if I do a request, if I do a pool of numbers, I want to specify what pool, P-O-O-L, that my pool, P-U-L-L, is in English a wonderful language where they sound exactly the same and mean something else. But yes, I need to expose the pool of criteria that will allow me to decide which set of numbers that I want to acquire, and then what set of serial number formats can I support in the pool request as well. And then there's a couple other things such as how many can I ask for at once, how many can you push to me at once, all these other pieces associated with it. So when you create as an equipment vendor a pool manager object, or you define the functionality, you may not have all of these in your system. You may only have a couple of these in the system you provide because you're not providing that set of functionality associated with it. You will probably have the bottom pieces on there, the serial number formats, the max returnable and requestable and pushable and these sort of things. But you'll see on the profiles are broken up in such a way that you can decide what functionality you want. That functionality tells you what methods you will be supporting. Hopefully that'll become a little bit clearer as we go through some of this here. The other piece we have is an event manager object. So we have serial number events, which are the events associated with serial numbers that have not yet been encoded into a label. And then we have a set of events for the labels and a set of events for the SIDs, the commissioned products themselves. So an event object manager is what your system would be if you receive events. Not if you ship, not if you cause events or send them out, but if you receive events. So again, The OPC UA model is that the server has objects. You perform methods on those objects. So you would have an event manager object, and you would decide which of these events you will be receiving from from a different level system, a higher level, usually a lower level system you'll be receiving. And then we have profiles where you will be able to specify for your product exactly which of those services you're going to be providing. So that's the event manager service. We also have the aggregation manager service. So for example, if your system is dealing with aggregations, so it's not just putting labels onto products, but it's also then doing the putting them into cases, putting them into cartons, putting them into pallets, etc., those sort of things. Then you need to also handle the aggregation packing events. Now, this doesn't mean you as the generator. Again, this is the receiver of the events. This is simply saying who can receive the fact that I broke a pallet apart and that I repackaged the pallet. Many times that's your MES system, or it could be your ERP system, or your site serialization manager, or your enterprise serialization manager, any of these. But you're basically saying that this thing will support receiving these methods, packaging events and unpackaging events. And then finally, we have the SID class, which is where we collect kind of the information about the SIDs specifically and the label properties. We have a whole set of specifications that are in the OPEN-SCS PSS that talk about the standard properties that are out there. A lot of these SID classes and properties are, again, using the GS1 terminology for what the properties are. So if you take a look at an EPCIS message, which is an XML structured message, you'll see a lot of fields in there with standard names on it. We've done the same thing here. We've picked those standard names, the tag names that show up in the XML messages, and said these are the properties that we can use to configure and define what is an SID class, and which, again, think of this as a product class or a final product class with labels on it. And what's the SID class and what are the labels, information associated with it. So a lot of this terminology that we have in PS and the PSS is really the GS1, and we actually have that in the OPC UA companion spec that we have to reference these. We have to use these properties associated with the system. That's kind of a requirement for somebody who says they want to be certified to the OPEN-SCS system. So now comes the fun part, because that's all very complicated. We've got whole sets of services out there. We got services that deal with the pool of serial numbers. We've got services that deal with the events that are going on. Services deal with the aggregations that occur. Now, how do you make sense of all of those things? Well, we make sense of them using what are called profiles, and they're client and server profiles. So profiles are defined in OPC UA Part 7. And what a profile is, it's a named aggregation of conformance units and other profiles and facets. So what's a conformance unit? A conformance unit is something that you test. So there's a test case for each conformance unit. So for example, a conformance unit may say, you support the XYZ event, and you will return this value if we send it to you. So if I send you an event, because you're a server, and I send you a brand new event, and I say serial number invalid, you should be able to receive that. Now, if it turns out that the serial number I sent you was not a valid serial number anyway, yes, you should be able to return in your test case that it didn't work. So there are test cases. So your application is run against, these test cases are run against your application based upon what profile you said you support. So the profile gives you the conformance units, which are defined in the OPC UA spec, the companion spec. Those conformance units will have test cases built for them. Those test cases will be run against your application based upon which profile you said you support. And then you get these OPC UA compliance tests, and then once it's complied, you'll be able to have a certification that says, yes, we comply to all these tests. What does that mean? That means that you work in the standard manner. And from a practical standpoint, what that means is that your system will play with somebody else's system without a lot of extra configuration. that needs to be set up. Most of the configuration will be setting up. You'll see on the security side that these two applications are allowed to talk to each other and that they have shared some common master data pieces of and definitions that are out there. So this is what a profile is. A profile is something that you as an equipment vendor say, my equipment will support these sets of services, these conformance units. And my equipment will be tested against the test cases for those conformance units. And if my equipment passes, then I have compliance with that profile. We do this really in two different ways. We do this via what we call plug fests. Now, plug fests are where the vendors, different vendors can get together and see if their systems will talk together. And that's what we did with a first release. And the plug fests are informal. We don't keep track of them as to who did what, but it does give the equipment vendors a lot of knowledge as to how close they are to following the standard. Then we have the compliance tests. The compliance tests are much more formal, and they actually are done in a compliance lab that has been certified by the OPC Foundation, so that we know that these tests are valid and run. So it's a much more formal thing, and you get a report back out of those. So we have two of those, and both of those are very valuable because a compliance test only tests against fixed test cases, not against other vendors' systems, equipment vendors. The plug fest lets you test against other equipment vendors and make sure you are both understanding the standard the same way and that you can work together seamlessly. So these are what the profiles are. So we have a whole set of profiles then that are also defined in the OPC UA companion specification. So for example here, we have a serial number event manager server profile and a client profile. So the server profile says, I support these methods. Somebody can call me on this object, so I've got a serial number pool, or an event manager server, and I support the invalidating event. The client is something that would be on another side. So let's say that is an MES system, and it's basically saying, I'm a client, I will make the call. I will make the procedure call of the SN invalidating event. So the client makes the request, the server does the response. That's the profile that we have defined. So there's a test case then that says, I'm going to test the client. And it basically says, okay, point the client to my test case server. Yeah, you send it to it. It's me. It's in the right format. I sent the response back. And then on my screen, I showed that I got the right data, something like that. Likewise, there would be a test case for the server that would say, okay, I'm a server, and then we would have a test case that would be simulating a client to make sure that you can actually receive the request and do something with it. But that's just one of those profiles. We have another profile which says I am a label event manager server profile. So I've got an event manager, but I deal with the labels. First one deals with serial numbers, second one deals with labels, and the events that my server has, it says, okay, I accept the label encoding, scrapping, sampling, and inspecting events. I will receive those events. Likewise, a client says I'm going to be able to send those. So for example, your label client might be your printer. So let's say I've got a printer out there and it's sending back, it says, yeah, I inspected the labels, which meant I printed the label, I had a vision system, yeah, everything was correct on the label, I'm sending you an event. Likewise, I'm scrapping the label because it ripped or because I couldn't read it or something like that, and I'm sending you the event. That's the client. The server in this case might be your MOM or MES system, or else a site serialization manager that is receiving those events and updating its own local database. So we have client profiles and server profiles. And then we have the same for SIDs. So if you take a look at the event manager, there's really 6 profiles that we have defined associated with it. One for the serial numbers, one for the client, and one for the server, one for the labels, label client, label server, and SID client and SID server. So these are handling all of the events that can come out associated with the objects we're talking about with the labels and with the commissioned products. So the first one was dealing with the events. The second piece, we talked about a pool manager. Okay, so the pool manager here is a serial number manager. The first one is I'm dealing with the unassigned serial numbers. Okay, so this may be no more than simply saying a higher level system, I'm managing the semi-random numbers, I'm making sure they're unique. If you ask me for them, I will give them to you, or I may push them to you at some regular basis. All I'm doing is managing the numbers at that level. They are assigned or unassigned. So in this case, I can make a request the unassigned, and it returns the unassigned. Likewise, I can have unallocated. So maybe I have a system which is managing unallocated. So at a site, because I know that I need to continue production, and if I lose my corporate system, I don't want to stop production. I may want to manage some of these unassigned serial numbers locally. So I don't always have to go hit a corporate level system every time. And if for whatever reason it's down or updated, or somebody cuts a fiber optic cable outside my plant, I can't talk to it. Maybe I need to manage those myself locally, so they're unallocated, and I need to manage the unallocated, or I need to manage the allocated ones, which are allocated to a batch or to a production run. So again, this is the case where maybe what I need to do is I have told you to make 10,000 of them, but you're only going to make 9,000 of them. So I'm going to do the return, the request allocated, the return unallocated, etc. So these are the profiles associated with managing the pool of serial numbers. And then finally, though, we have the serial numbers that go down to the encoded. So this one's named a little bit different, but it's really the print and commission manager server profile that basically says at the point in time, the serial numbers go to something where they're going to be encoded and then placed onto the products. That's where we use this. So one profile, which is the to encoded profile, where I make that request and I get the data back. So these are profiles that we have defined that says this is what you as an equipment vendor would be specifying which pieces of it you support, what pieces you support. So here's all of them together, and this is a figure that's actually in the PSS, the packaging serialization specification, with all the different profiles. So it looks confusing, because there's a lot of different options on there. But the thing to remember is that not every product that a vendor builds is going to support all of these pieces. It doesn't have to. It doesn't provide that level of functionality in a system. So to show you a little bit about how that might be partitioned out, so let's say an MES to a printer scanner. Okay, that's what it is. So the MES system is going to talk to a printer and a scanner, and what we've got there is the MES has to say, the printer and scanner profiles need to say, okay, I am a printer, and therefore I will receive the two encoded messages. I will receive a set of serial numbers that are supposed to be encoded, okay? I will also be a client to say, okay, here I am responding back to the MES that says me as the printer and scanner will come back and say, I will report on labels encoded, labels scrapped, labels sampled, labels inspected, the aggregation packing event associated with it, putting it into a carton or a case, and the unpacking event, probably not the unpacking, but at least the packing. So me, as an equipment vendor, would say, okay, given all of these profiles, the only ones I really need to support are three profiles. So I would create, the print and commission server profile, which is a part of the pool management profile, and I would be event clients, and that's all I have to do. So if I go to the OPC UA certification lab, I would say, these are the three profiles, test and make sure that I am doing these correctly. So test and make sure that I am calling the label encoding event correctly and the aggregation packing event correctly. And I may specify in my test that says I don't support the uses unpacking event, I only do the packing. But this is the sort of thing you as the equipment vendor get to decide what to do. So yes, it's complicated, But for individual equipment vendors, it's not quite as complicated as it looks. So here's the MES side of it. So the previous one was what's the printer side. Here's the printer side. Okay, now this one is the MES side of it, and I probably should have highlighted the aggregation, but it's saying I, as a server, I receive the label encoding, I receive the scrapping, I receive the sampling and inspecting events, and I use the SN2 encoding. I use the SN2 encoding to send the serial numbers to the printer as well. So if I have an MES system that wants to talk to a serialization-enabled printer, then these are the printer scanner profiles that I would need to support in my product. If I don't talk to them, I don't support these profiles. This is very, very straightforward. Next one, let's say I'm recording the events. So I've got an MES system that's recording all the events on labels and SIDs and then sending them up to the higher level system. Okay, so it's basically going to be a client, and it's going to accept all these recording events or determine internally that these have happened and ship them off to a higher level system. Likewise, I might be managing unassigned events associated with it. Again, look at the functionality that you have provided in your product, because that functionality is the functionality that defines what profiles you support, which define what tests that will be made. And then if you're a system integrator, you look at the profiles and you say, oh, this one has this client, this one has these servers, they're both certified. I know that they will work together. I know that this client will talk to this server, and the most I have to do is some minor configuration of the systems to make them work together. So summary, all these different profiles allow all these different architectures. Remember, we said we're not defining an architecture, we are defining interfaces. So the profiles define the interfaces. You as vendors, equipment vendors, you get to decide what your architectures are. You as the end user manufacturers, the pharmaceuticals, the biotechs, et cetera, you get to decide how you want to configure those different systems together, which functionality from which vendor that you want to apply in your system. Any single vendor will probably have to support multiple profiles, just as I pointed out. There may, simple printer scanner has to support probably 2 or 3 different profiles. All profiles have these very specific tests, so it becomes plug and play with, almost plug and play with automatic configuration. So remember, I said some of the configuration information was what's the maximum number of events that can be recorded or pushed, or the maximum number of serial numbers that could be pulled. All those things, the one system can ask the other system of, and then auto configure itself. So you don't need to manually go in there and set sizes and correct things. And if you've got information on your SIDs and your labels, you've got the information you can use to create pull down menus for operators and others to say, okay, what products, what SIDs, which are the commissioned products, do I support? Okay, what label format is available, those sort of things. So you've got the automatic collection of it for drop-down menu selection or validation of functionality of the systems. So profiles help us a lot, and they help us a lot by making sure that we are as close to plug and play as we can get with the information there for auto configuration of the communications that are in there. So this is how it all worked together, assuming everything works correctly and assuming that everything is secure, because security is important. What we want to make sure is none of these events and none of these messages and none of these serial numbers can be spoofed or looked at. Serial numbers are worth money. If you, as somebody doing an illegal act, wanted to get into these systems and pick up serial numbers and use them, we want to make sure that that doesn't happen. For example, you might want to be able to break into the system and pick up all the commission serial numbers, because you know you can print these fake labels and make these fake products and get them into the supply chain before the actual manufacturer can. So those numbers, they're valid, but guess what? They may be in the supply chain from the drug manufacturer for weeks or months before they actually get to the pharmacy. You can get your stuff out quicker, and guess what? All those numbers will show up as valid. You don't want that to happen. You want to have secure communications. And in order to do that, we would use OPC UA security. It's very critical. These serial numbers, they have value. They can be stolen. They can be worth money. They can be worth lives, essentially. If somebody is faking a cancer drug and giving you something that's not the correct drug, you may think it is, but it's not, and people die as a result of that. So there is a lot of security that's built into it. And part of this is the event management is critical, but part of it is the fact that in order for two different systems, a client and a server, to talk together, they have to go through several levels of security. And it has one of the most comprehensive and complete security models of any industrial network. In fact, it is the recommended one model that's being used now for a lot of the secure communications that are going on in edge devices and others, where there's a lot of checking to make sure that I've got a valid certificate that people can actually talk. I create sessions, I pass user IDs, I have encrypted communications, I can close the channels. A lot of work has gone on. And to a large extent, a lot of the work that goes on in the Plugfest is to make sure that people are implementing the security correctly. It is a bit of work, but it is extremely valuable because each of these serial numbers actually has values. And to give you some idea what we're talking about, the multiple levels of security that can show up. There is user level security, user security tokens that are passed back and forth between the client application and the server application. These are the standard username, passwords, Kerberos systems, different methods there. There is authentication of the sessions themselves that are set up between the application, between the different servers, the clients and the servers. And then finally, there is signed and encrypted communications at the transport level so that this information isn't going across in plain text or in open text, so it can be encrypted as well. So you have multiple levels of encryption, multiple levels of security. So part of setting this up is to configure these correctly. And the OPC UA companion spec has a whole set of definitions as to what is required for a client or a server platform. And there's a set of profiles associated with it. So if you say you support any of the other profiles that are in there, you will implicitly have to support also all of the security profiles that are defined as part of the OPC UA companion spec and model. So very, very secure system. If things don't get configured correctly, they won't talk, but that's exactly what you want in terms of security. You don't want somebody being able to get at this information and quite possibly putting falsified drugs, counterfeit drugs into the supply chain, and with the resultant costs, both of human lives and of money. So this is where we are today. This is what we've got. We've got a set of profiles. We've got a set specification that says you what the services are. We've got the communications and security set up. We've got the tests in development for those. So we will have certification set up as soon as we get go through the final pieces and start to set up the certification services. All these things will be available soon or relatively soon and ready to go. And but as I said, what we're doing is we're also working on some future pieces here. And the future pieces in the near term, what we talked about is the job order management. Remember, I already talked about that. We'll use the ISA 95 models. They're well known, they're widely used. The job order, the packaging order is really just a specific type of job order. But by using the job order, we can also include repackaging orders, so you can come down and say for your warehousing or your distribution, this is the redistribution of it. I want to take this material from these pallets and put it and redistribute it into other pallets. We've added the job order control, so you can store download a job order and store it, or you can download the job order and say sort and start as soon as you're ready, because the equipment has to be ready. Or you can start a one that had been stored down there. You can update one that has been stored, stop, cancel, and clear. Likewise, we want to find out what actually happened to the job. So we've got a job request that says, what's the current status of the job? Has it been started? Is it running? Is it paused? How much of it's been done? Those sort of things. And then we have a job response report, which typically will be configured to go at the end of a job. At the point in time that you finished your packaging run, either the operator presses a button that says I'm done, or you have some mechanism in place to automatically determine when you're done, and you want to send that report back up to a higher level system. You know, may go to an MES system, or it may go from an MES system up to an ERP system. So we're going to use that. Near term, we've got those in work, in development. We've already started the review process on these, including the use cases and started the draft of the PSS. Likewise, we're including the master data and using the ISA 95 models and the OPC UA ISA 95 companion spec, because that already exists. There's already test cases for it. There's already implementations of this. This is already done. This is going to make it a whole lot easier for us to do additional work. Steps after that, we talk about sending EPCIS encoding events for a large number of events. Now remember, OPC UA is really designed for transactional, real-time information exchange, so I can talk to my printer and from my MES to my printer in real time and not have a whole lot of delays. I can talk from my ERP to my MES and have limited delays. But as we move up into the supply chain, what we want to do is we want to take a lot of the event data that we have, which we are exchanging maybe in real time, because I may be commissioning, you know, 200 products a minute. Now, and I want to collect some of those together because I don't want to do 200 transactions a minute. I may say, okay, these 200 were commissioned, and then every minute send it. But even that is a high rate of exchange for a higher level business level system and a supply chain system that's managing it. So the thought here is that what we're going to do is to have another function, set of services that are available that will take the event data and in the EPCIS format, be able to send those using the OPC UA as the transport mechanism. Now today, there's many different ways to do the EPCIS communication transport. You know, people are using message-based systems, or using file transfers, some people, you know, emails, all sorts of things. Well, we want to protect this information from our side of it, so we're looking to use the OPC UA as the transport mechanism to potentially send tens of thousands of events in a single transaction. Typically, you wouldn't be using it, but the idea here is that we don't want to be size limited, we don't want to be space limited, and we don't want to overrun the bandwidth of the network systems that we are currently using. So we're going to come up with this. It's based upon existing methods and functions that are available in the OPC UA specification, and it'll allow you to easily take the EPCIS XML messages from one of the systems we'll be providing, and then putting them into your supply chain as well. So these are the next steps of what we're planning, and we'll have these steps done this year. So in summary, OPEN-SCS defines those standards for interoperability of serialization equipment, for these things to work together, to define a near plug-and-play functionality where all you have to do is minimal configuration. You don't have to do programming to make these things work together. It provides the secure transport standard for exchange of these numbers. Serial numbers have value. They have value to criminals. They have value to crooks. They have value for people who will falsify data or provide substandard, or falsify drugs, or provide substandard drugs or counterfeit drugs. So the information needs to be protected so they can't get at it. It defines testable standards so that you as an equipment vendor can ensure that your products meet what the standard is. And we provide plugfests where you can ensure that your products will work with other people's products, okay? It defines profiles. It can be used in many different implementation architectures, so we have a lot of flexibility in how the equipment manufacturers can use to configure their equipment and make sure that it's going to work correctly. and do what they think it wants to do. And then from the end users, they can look at the equipment that they have provide and see what profiles they fit and see if they will plug and play together. Obviously, if they go into an environment and they say, I need to do X and this vendor doesn't provide it, but somebody else does, well, that maybe it makes the selection easier. Or else the vendor who doesn't provide it may say, I'll extend my product to support that. But you will know early on whether or not these things are going to work together. It is real and it is ready to be implemented. The OPEN-SCS OPC UA companion spec is ready. We've had our first plug fest. We have actually had the second virtual plug fest due to the issues associated with the coronavirus. We are performing these things virtually, and because of that, we know that the pieces are going to work together. It is real. The specification is complete. If you're familiar with OPC UA, you recognize that we have not just the specification, but also the node sets, which are the basically the graph databases that define the models that we have. We have the specs real. We have plans right now for the future ones, which are going to be the master data, the job orders, and then the EPCIS data. You can start today. That's the message. There is no reason to wait. There are test cases in development. There are specifications complete. There are plug fests that you can attend. Today, you can actually use this to start to build serialization, track and trace solutions rapidly to build them according to a standard and ensure that they will work with other vendors. So if you just go to www.open-scs.org. You can see some information associated with this, and you can contact the people who will help get you involved in this to both attend the Plug Fest, to help understand the standards, and to basically build your products. So I want to thank you very much for listening in on this conversation and this discussion, and I wish you all the best. And please go to OPEN-SCS.org and learn all about all the functions and all the things that you can do associated with the OPEN-SCS specification. So thank you.
Thank you, Dennis. That ends our recording today.